This video will show you the various transformations applied on one graph, and the graph, our default graph, will be the sine graph. If you've watched my previous videos, it has already shown individual videos on each transformation, and this one is just combining all of those transformations. So I'm going to put in another equation, and this time I'm going to put a constant. The first transformation will be a constant outside a function. So if you put a constant outside a function, it will stretch your graph along the y-axis. So as the constant increases, so is the stretch along the y-axis. And when it gets to negative, if the constant before the function is negative, it will show you a reflection. So this red graph has been reflected onto along the y-axis. Now, if we put a constant inside the bracket, and in this case the constant is multiplied with x, we will expect a compression. So using the constant controller, we're going to be increasing the constant. So the greater the constant, the more compressed is your graph. So if we stop the controller at 3, your graph would have been compressed by a third. So from 90 divided by 3, a third of that will be 30 degrees. So if we put a constant inside the bracket this time, the movement will show that if you subtract a value inside the bracket, the movement of the graph will be going towards the right of the x-axis. And if you add a constant, it will move your graph along the x-axis to the left. So let's have a look. So that's for the letter C, constant. Because we're moving our graph along the x-axis, so our scale should be by degrees. So in here I'm going to be putting 30 degrees. So the movement will be 30 degrees along the x-axis by 30 degrees. So in here, so that's 30, 60, so that's moving 120 degrees to the right, because you got a minus here. So minus a positive value will move the graph towards the right. And if you have a negative value this time, like negative 30, so that will be a minus 30, that becomes a plus 30. So adding a value inside the bracket will move your graph to the left. So now I am going to be adding a constant outside the function, so a plus d. So if you add a constant outside the bracket, that will move your graph up or down. So if it's a plus, it moves it d units upwards, and if it's a minus, moves the d units downwards along the y-axis. So the graph is moving up there and is moving down, translated down as it goes negative. Now I've put the graph back on default mode, and I'm going to be putting in actual values into our variables. So for A, I'm going to be putting 2, and let's see how it moves. So as you can see, the graph has been stretched 2 units along the y-axis. Now if I'm going to be replacing B this time by a constant 3, so we should expect the graph to be compressed by a third, which it has. So you can see the change, the transformation from the red original red default graph into our brown colored graph. Now if I'm going to replace C by 45 degrees, so the graph has been moved 45 degrees to the right, as shown here. Now I'm going to replace the D with a constant 1.5, so we should expect our graph to be moved 1.5 units up. So that's your translation. So to see for a better view, I'm going to reduce the size, which I have, and you can see the movement there. So the default graph is the red graph for sine, and this is the transformation by the values I put in here. So the original graph, y is equal to sine x, has been stretched 2 units upwards, and has been compressed by a third and moved 45 degrees to the right and translated 1.5 units upwards.